Okay. This is the 2012 AP Calculus BC multiple choice, section 1, part A, no calculator section. Alright, so the time for this is 55 minutes, but I believe we can do it in way less than that. Alright. Okay, number 1, if y equals sine, so we have sine to the third of x dy dx is equal to, alright, so y is just equal to sine x to the power of 3. So then we want to find dy dx. We do the power rule, so then we bring down the 3, then we have sine, and then we have to multiply the derivative of inside, which is chain rule. Then that means my answer is 3 sine squared of x cosine x. So my answer is E. Alright, number 2, the position of the particle moving in the xy plane is given by the parametric equations x of t and y of t, at which point xy is the particle at rest. Okay, so if it's at rest, that means the speed of velocity is going to equal to 0. So let's first find where the particle is at rest. So the velocity in the x direction has to be equal to 0, and the velocity in the y direction has to be equal to 0. So let's first find x prime of t, which is equal to 3t squared minus 6t. So it's just the power rule. And then y prime of t is equal to 12 minus 6t. And then I'm going to set each equal to 0, so I can see at what value of t is x of t equal to 0, and at what value of t y prime of t is equal to 0. So I meant x prime of t. Let me set this equal to 0. So let me just factor out a3 and the t. So t minus 2 is equal to 0. So t is equal to 0 and at 2. So now for y, so 0 is equal to 12 minus 6t. So then t is equal to 2. So it seems like my t is at 2. So then now I want to find the position. So let's find x of 2, which is equal to 2 to the power of 3 minus 3 to the power of 2. And that's 8 minus 3 times 4, that's 12. So then that is negative 4. And the answer is A. Don't even have to find my y of 2 because there's only one that has negative 4 as the x coordinate. And also for the updated exams, there's only 4 options, A, B, C, and D. They took out E. Alright, the graph above shows f. What is the value of integral from 0 to 4 of f of x dx? So we're just finding the area here. So we're going to break it up into 2 sections. First, let's find the area of this section, and let's find the area of this section. So this over here, that's 2, and then 2 times 1, 2, 3, 4, 2 times 4. So then this is 4, so triangle, and then I have 2, and then 1, 2, 3, so then that's 6. So then my positive area is 6, and then my negative area is also 6. So then the answer is B. So my integral, you break it up into 2, you find an integral from 0 to 2, and then you find an integral from 2 to 4, and then you add it up. Okay, which of the following gives the length of y equals ln x from x equals 1 to x equals 2? So when you're looking for arc length, for when you're looking at like rectangular coordinates, that's equal to the integral from a to b, so whatever your bounds are, square root of 1 plus f prime of x squared dx. So then in this case, our bounds are from 1 to 2, and then square root of 1 plus, so the derivative of ln of x is 1 over x, and then I'm going to square that, dx. So then that's equal to 1 plus 1 over x squared dx. So the answer is A. Alright, the Maclaurin series for the function f is given by blah blah blah. What's the value of f of 3? So let's plug it in. F of 3 is equal to, so I have from 0 to infinity, negative 3 to the 4 over n. So we have a geometric series here, and the formula for that, so for the sum, so this is what this converges to, not what the sum is equal to, and the only one that we know what it is for geometric series. The other ones we don't really know. Well, you don't know for this class. So what you do is you take the first term, which is negative 3 over 4. Actually, no, that's not the first term. You plug in the first term, negative 3 to 4 to the 0, which is just 1, and then 1 minus the ratio, which is that. So then we have 1, and then 1 plus 3 over 4. So it's 1 over 7 over 4, which is equal to 4 over 7. I take the reciprocal, so the answer is C. The formula for that is the formula for like the sum for the geometric series is you take the first term over 1 minus r. R is whatever's under whatever's being raised to the power of n. So that's good to remember. That is dependent on what your first term is. In that case, I would just plug in my lower bound to get my first term. Make sure you know that. Okay, using the substitution u equals blah blah blah, the integral is equal to which of the following. So u, so this one we're doing a u step here. So my u is equal to x squared minus 3. Let's get my du. That's just 2x dx. So I'm just taking the derivative and kind of moving the differential over to the other side. Okay, so my integral, so I have an x over here. So let's get my x by itself. That means 1/2 du is equal to x dx. So my integral. So my bounds are in terms of x. So I have to turn it in terms of u. So I have to plug it in here. -1 squared, that's 1. 1 minus 3 is -2. And then for my upper bound, I have 4 squared, 16 minus 3, that's 13. And then I have 1/2 u to the 5th du. Alright, it's just plugging it back in. And I think my answer is C if I pull out the 1/2. So this is just 1/2 to go from -2 to 13 of u to the 5th du. Okay, arc sine x equals ln of y, then dy dx is equal to. All right, so this is implicit differentiation. So for arc sine, it's just 1 over square root of 1 minus x squared. You need to have that remembered. And the derivative of 1 over y with respect to x is equal, ln of y with respect to x is 1 over y times dy dx. So you have to multiply by dy ex because it's the chain rule here. And then in order to get dy dx by itself, I would get that by itself. I would multiply y on both sides. So I get y over 1 minus x squared. So for number 7, the answer is A. All right. Riemann sum. I hate it when this is not a calculator question. Okay. A tank contains 50 liters of oil at T equals 4. Oil is being pumped at a rate RT, where RT is measured in second, T is measured in hours. Select the value of R given in the table above. Using a right Riemann sum with 3 subintervals from the data from the table is an approximation for the number of oil that are in a tank at T equals 15. All right. So in order to find how much is in the tank, I have to use like the accumulation of change formula. So first, I start at 50 liters at T equals 4. And I want to find when it's at 15. So it would be from 4 to 15 f R of T, the rate. So you must remember your 50 to find out what it is. And that's approximately 50. And then now I'm going to do my right Riemann sum. So my interval for 7, 7, 12, and then 12, 15. I'm taking the right sum, so I'm finding the value of R at those points. So 50. Okay, so then that's equal to R of 7 times 3. I'm too lazy to write it, so it's just 6.2 times 3 plus 5.9 times 5, and then plus 5.6 times 3. Yeah, I believe so. So then that means this is approximately oh god, it's a lot of work. Well, on the actual test, you cannot use a calculator, but I'm a little lazy. So let me use a calculator. 3 plus 5.9 times 5, 5.6 times 3, I get 114.9. So the answer is C. Okay, Which of the following series converge? So, this one you kind of have to know between like factorials and exponentials. So, one is convergent. So one is convergent. That's, yes, it's convergent because I have the factorial in the denominator. My exponential, that's in the numerator, but factorial, it kind of like reaches zero faster. I mean, it reaches infinity at like a faster rate. So yeah, you kind of have to just memorize that one. For 2, it does not converge because, again, like I said, the factorial reaches to infinity faster than well, this one is just, this one's a power, so then the power even goes slower. So this one fails by the n term test, because the limit as n approaches infinity of n factorial over n to the 100 does not equal to 0. That's not true. And for this one, so the power is n, and then the denominator is n to the power of 3. So that's just 1 over n squared. So that it will converge by a p-series. Sounds good. So the answer is D, 1 and 3. So for this one, you do have to know for like, basically, if you have a factorial, if it's in the denominator, probably is going to converge. Okay. So this integral, solving this integral. All right, this integral is easy. It's just taking the it's just the reverse power rule for integrals essentially. So I'm gonna add 1 to the power, so plus 1, that's negative 1/2, and then I divide it by the power, so then I is multiplied by 2, and then I'm evaluating it from 1 to 4. That's negative 4 to the, so okay, that's just negative 2 over root t evaluated from 1 to 4. All right, just rewriting it. So negative 4 to the root, sorry, negative 2 over root 4 minus negative 2 over root 1. So then that is negative 2 over 2 plus 2, which is equal to negative 1 plus 2, which is equal to 1. So 10, the answer is E. All right, the function defined by blah for all x, which of the following statement is true? Okay, so for this one, you have to see which one it is. All right, so which of the following statement is true? All right, so it seems I have an absolute value here, and if you know for the absolute value, normally you have a cusp here, and that's going to be a problem. So I already know the answer is A. It can't be differentiable because when you have x minus the absolute value of x minus 2 at x equal to 2, you have that cusp over here, that sharp turn is not differentiable there. So we know that it's not B. If the whatever's inside the radical is not differentiable, then when you add the radical, it's not going to make it differentiable. Is it continuous at x equals 2? Yes, it is continuous. It's approaching the same point. It's continuous, yeah, and then the limit is not, yeah. Which of the following is true? So yeah, and then D, if you plug it in, is equal to 0. X equal to 2 is a vertical asymptote of that. Because you have the square root, then the vertical asymptote makes sense. Well, the answer is A. That statement is the only one that's true because of the cusp that we have there. All right. The points -1, -1, and 1, -5 are on the graph of a function y equals f of x that satisfies the differential equation. To write dx equals x equals y, which of the following must be true? All right. It seems like we are looking at local maximum and also point of inflection. So most of the answer choices are about the local minima. So I'm just gonna look at the the local extrema. So I'm just gonna plug it into dy dx and then see what value it's equal to. Because in order for it to be like a local extrema, dy dx has to be 0. All right. Strategically, you know what I'm gonna do? It seems like most of the choices are -1, -1. I'm actually gonna plug that one first. Guessing is also good. Like, one of the techniques is that whoever came up with these questions, they will have a right answer first, and all the wrong answers are branched off from the right answer. So kind of like with the most similarity with the other answers, that's probably the one that's correct. So let's plug in dy dx. So let's try out the -1, -1 first. So dy dx evaluate at -1, -1. That's equal to -1 squared plus -1. So that's equal to 0. Okay, that's good. So now let's see what's going on. All right, let's find the second derivative. So I have to do implicit differentiation. So 2x, so that's my x term, that's good. And then y, that's just equal to 1 dy dx. All right, because I have implicit differentiation. This is just 2x. Implicit differentiation or chain rule, it's about the same thing here. So that's 2x plus x squared plus y. So now let's evaluate the second derivative, whoopsies, at -1, -1. That's equal to 2 -1 plus -1 squared, and then plus -1. So I have -2 plus 1 minus 1, so then that's -2. And I like to draw my little sad face. So I have a local maxima because my second derivative is negative. So the answer is C. All right. What is the radius of convergence for the series? So I'm just gonna do my ratio test. So then my lim, and then I'm gonna do so my n plus 1. So then if I plug in n plus 1, the 2n plus 1, that's equal to 2n plus 2. Just gonna simplify that here. And then 3 to the n plus 1. And then since I'm dividing it by the original one, it's just multiplying by its reciprocal, times 3 to the n over x minus 4 to n. So now that is equal to, so it's just something over 3. It's just x minus 4 squared over 3. And in order for it to converge, it has to be less than 1. So then my x minus 4, well, the absolute value, has to be, x minus 4 squared has to be less than 3. So then my x minus 4 has to be less than root 3. So then my radius of convergence is c root 3. Okay. Let k be a positive constant. Which of the following is the logistic differential equation? This one you just have to know. Is the definition of a logistic equation. Your dy dt is equal to ky times 1 minus y. That's just like the general formula for it. You have to know it, and with the logistic differential equation, you're gonna have your like the population. Usually we're dealing with terms of population, and that's going to be in the equation itself. Okay, the graph is a differentiable function. Sorry, the graph of a differentiable function f is shown above. If h of x is equal to integral from 0 to x of f of t dt, which of the following is true? All right, so let's find h of 6. So h of 6 is the integral from 0 to 6 of f of t dt. And we know that that's going to be negative because you have this whole entire area here. And that is negative. So that's less than 0. So h prime of 6. So then now by the fundamental theorem of calculus, well, if you take the derivative of this, it's just f of x. Now you're just plugging in the upper bound, and then if it's a function, you will multiply by this derivative, but in this case it's not, so we don't have to worry about that. And that's equal to f of 6, and then f of x 6, that's equal to 0. Now h double prime of 6. So then again, if you take the derivative again, that's going to be equal to f prime of 6. And then f prime of 6, since my slope, it's increasing there, so then that's going to be greater than 0. So then that means it's going to be, the answer is going to be A. All right. Let y equals f be a differential, solution to the differential equation, blah, 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 with the initial condition f of minus equal to 3. What's the approximation of f of 2 obtained by Euler's method of equal size starting at 1? All right, so we know that f of 1 is equal to 3. So now let's do f of 2. Oh, 2 step size, sorry. So then f of 1. So then my step size h is going to equal to 0.5. So in order to do Euler's method, you do the previous term plus step size times the derivative at the previous point. So x minus y, so then 1 minus 3. So this is equal to 3 plus 0.5 times -2, so minus 1, -1. So then that's equal to 2. So then f of 2. So then now we do it again. Sorry, this will be approximation. 2 plus step size 0.5. And then now you have the x minus y, 1.5 minus 2. So then that is equal to 2 minus the, so then it's 1.75, I believe, if I'm not mistaken. And that is 7 over 4. Yeah, 7 over 4. So then there's that. Okay. The power series converges to which of the following? This one you have to kind of be able to recognize. So, cosine. So it's definitely not cosine because cosine you have the even powers here, and then your denominator is gonna match up, and it's also gonna be even. So it's not that. Sine. Sine is not sine because this power and then this number down here, they have to match up to each other. The answer is C. When you divide it by x, then the power decreases by 1. So then there's that. And then when you have e to the x, then that's not any of this here. All right. The graph of f prime, the derivative of f, consists of two line segments and semicircle as shown above. If f of 2 is equal to 1, then f of negative 5 is. So f of 2 is equal to f of negative 5 plus integral from negative 5 to 2 of f prime of x dx. So this is like the accumulation of change formula. So then f of negative 5, that's equal to f of 2 minus integral from negative 5 to 2 of f prime of x dx. And that's equal to 1 minus. So from negative 5 to 2. Okay, so that's this circle. So I'm stopping here. This is 2 square, 4 square. So this is 2 pi. And then this is 3 times 2. So then this is 3. So then I'm minus 3 minus 2 pi. So that's negative 2 plus 2 pi. So my answer is A. All right, this is the accumulation of change. And basically the fundamental theorem of calculus. You have to know that one. All right. The function defined by f, which point x y has a property that tangent has a slope of 1/2. So basically, we want to find the point at which the derivative is equal to 1/2, because I'm finding the slope of the line tangent. That's basically the derivative. So let's find the derivative of f prime of x. So this one I would do the quotient root. So low d high, which is just 1 minus high, and then d low, which is also just 1. And then over low or low squared. So then this is equal to 2 over x plus 2 squared. And I want to see when it's equal to 1/2. So 2 over x plus 2 squared, that's equal to 1/2. So then 4 is equal to x plus 2 squared. So then if I take the square root, I have plus or minus 2 is equal to x plus 2. So then negative 2 plus or minus 2 is equal to x. So then my x is equal to negative 4 and 0. So it seems like my answer is C. Those are the only ones that satisfy it, the x value. All right, the integral from 0 to 1 of blah, blah, blah is... All right, so this one, I think we are dealing with partial fraction decomposition. So what I like to do first is I like to just break this down because I don't really like doing this. All right, so factor the denominator. So I think it's x plus 1. X plus 2, I believe. Let me just double check. Yeah, okay. And then that's equal to, so then that's going to equal to a plus 1, b over x plus 2. All right, I hate partial fraction decomposition, but whatever. So then I multiply everything by the greatest common denominator. So then a times x plus a times x plus 2 plus b times x plus 1. So then my 5x plus 8, that's going to be equal to 8x plus 2a plus bx plus b. You can just plug in like negative 2 or negative 1, sure. But this way is more generalizable. A plus b has equal to 5. 2a plus b has to equal to 8. And then a is equal to 3, so then b is equal to 2. So then that means this is equal to 3 over x plus 1 plus 2 over x plus 2. So then my integral, I'm taking up so much space. Let me just rearrange this a little bit. Oh, shoot. Okay, let me do my integral in a different color. So from integral from 0 to 1 of this function x squared plus 3x plus 2 dx, that's going to be 0 from 1 of 3 dx. So then that's equal to, so the antiderivative of this is just 3ln plus 1 and then plus 2ln x plus 2, and then I'm evaluating this from 0 to 1. So then I have 3ln3 plus 2ln, sorry, 3ln2 plus 2ln3, and then minus, ln of 1 is just 0, and then 2ln2, so then I subtract it, so then I have ln2 plus 2ln3, so now if I add, so then this is just equal to ln of 2 plus ln of 8, so then that's equal to 2 times, oh shoot, that's not new, oh shoot, sorry, messed up here. Sorry, this will be 9, because I brought the power here, I don't know why I wrote 8, and then I can multiply whatever's inside, log rule, so then this is ln of 18, so 20, the answer is C. All right, it's a tough one. It's a lot of work. Partial fraction is a lot of work. Okay, the line y equals 5 is a horizontal asymptote to which of the following functions? So when I'm looking at horizontal asymptotes, I want to see the limit as x approaches infinity or as x approaches negative infinity. So let's see. Okay, so the answer is E. So for this one I would just kind of see it. This one goes to infinity or negative infinity. Well, this is a straight line, so it can't have a horizontal asymptote. This one, the horizontal HA is at y equals 0 because you have the 1 over thingy. This one, if you're just looking at the powers, so when you're looking at infinity, limit to infinity of a rational function, you just look at the leading term, and then you look at the coefficient of the leading term as the ratio of the leading coefficient. This one will be y equals -5, and then this one is y equals 5, so you know it's that. And then for that one, the limit as n goes to infinity is a little bit trickier, so I already have the right answer, so I'm not gonna worry about that. Okay, number 22. The power series, blah, 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 converges to 5. Which of the following must be true? All right, so for this one, my center is at 3, and then so it converges at -5. So my R is at minimum 2. It converges at 5. So then now series diverge. So we know that at minimum, it's going to be from, so let's just use open interval to be safe. At minimum, it's going to be from 1 to 5, because I do plus or minus 2 of the 3. So we know that within that interval, that series must converge. All right, so A is not true. B is not true then. So which other one? So C, we don't know if that's true because we don't know what it is on the other side. So not that. So the answer is D, must converge at, so 2 is within this interval, and then 6 is outside the interval, so this is wrong. All right. P is the size of the population, linear growth. So the when you have a linear growth, your differential, your d something, it's gonna be equal to a constant. So the answer is A. We're dealing with linear growth. So let's say we have like y equals like 2x. This is a linear line. Right, dy dx, that's equal to constant 2. That's what it means for linear growth. Okay, number 27. Let f be a differentiable function such that blah blah blah. Integral of f of x sine x dx equals blah blah blah, which of the following could be f of x. Alright, so when we have like the multiplication like between two functions, we're probably dealing with integration by parts. IBP, and we have to know, so we have our function f of x sine x dx. We're gonna find out what our u is, our du, and then our v, and then dv. Okay, so I'm assuming, so by looking at this, I have the negative. So I think my dv is sine x dx, and if I integrate that, I get negative cosine x. And then my u should be f of x, and then my du should be f prime of x. So then, oh, whoops. So then that means this integral. So when I have u dv, that's equal to u v minus integral of v du. That's integration by parts. So then that means that integral, this over here, is going to be equal to u times v, which is negative f of x cosine x, minus integral of v, which is negative cosine x, and then my du, which is, this will be f prime of x dx. So then if I just take out that negative sign, so the negative f of x cosine x plus integral of f prime of x cosine x dx, and that means f prime of x is equal to 4x to the power of 3 from looking at the question. And which of the following could be f of x? So let me just integrate it. So then f of x is equal to x to the power of 4 plus c. So which of the following? So 24, the answer is E. Okay. 25, I have that integral, okay? All right, so when we have an improper integral, we want to basically like take the limit of it. So this is equal to the limit as b approaches infinity to go from 1 to b of e to the negative x squared dx. You can do a u sub here. So my u is going to equal to my u is going to be negative x squared. So then my du is going to equal to negative 2 x dx. So I have an x here. So then that means negative 1/2 du is equal to my x dx. So then my b to the, you know what I like to do? I actually do not like plugging in the bounds. What I like to do is just evaluate this integral on the side, so then I don't have to worry about the bounds. So then that's equal to the integral of negative 1/2 e to the u du. So then that is just equal to this will be du, negative 1/2 e to the u, and then my u is negative 1/2, so negative 1/2 e to the negative x squared. That means this, if I go back to the original integral, is limit as b goes to infinity of, so I solve that integral, which is just negative 1/2 e to the negative x squared. Evaluate it from 1 to b, so that's integral as b goes to infinity of, so negative 1/2 e to the, so if I have something to negative power, so this is just e to the, 1 over 2 times e to the negative b squared, and then minus, so this is plus 1/2, 1 over 2, yeah, and then that's equal to 0, so it's just 1 over 2e, so then that's just equal to 1 over 2e. So 25, the answer is B. All right, you have to know a little bit about exponent rules. Might be a little bit clearer if I wrote this. Negative 1 to the x squared, evaluate from 1 to b. Let me just move this over. And yeah. Okay. All right. 26. What's the slope of the line tangent to the polar curve r equals blah 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 at theta equals 0? All right. So we want to find dy dx. So that's equal to dy d theta over dx d theta. So, okay. So we have y is equal to r sine theta. You need that memorized, so make sure you have that. Alright, you can implicitly differentiate here, but I like to plug in. So y is equal to r, 1 plus 2 sine theta then that means y is equal to sine theta plus 2 sine squared theta. So then dy d theta is equal to cosine theta. And then, hold up, this makes it a little bit harder for me to see, so I'm actually gonna do this. Plus 4 sine theta times cosine theta, my chain rule. So then let me just actually, you know what, let me look at my x first. X is equal to r cosine theta. So then x is equal to r, which is 1 plus 2 sine theta times cosine theta. So then x is equal to cosine theta plus 2 sine theta cosine theta. And if I want to find dx d theta, that's going to equal to, so that I have negative sine theta, and then plus, now I have to do the product rule, which is the annoying part here. I hate solving for these types of questions. I hate it with a genuine passion. Okay, so keep the first, and then times the derivative of the second, which is negative sine theta, and then plus derivative of the first, and I keep the second. So yeah, that. So I have negative sine theta plus minus 2 sine squared theta, and then plus 2 cosine squared theta. All right, let me evaluate it each at 0. So dy d theta at theta equals 0. That's equal to cosine 1 plus, that's just 1. And dx d theta at theta equals 0. That's equal to, so then I have 0, and then 0, and then 2. So then 1 over 2 is 1/2. 26 is B. So let me just write this. D at theta equals 0 is equal to dy d theta. dy d theta evaluated at theta equals 0 over dx d theta evaluated at theta equals 0. All right. As you can see, my handwriting progressively gotten worse throughout this problem, as if the handwriting was not bad enough. All right, for what values of p will both series converge? All right, so the first one, we have a p series, and then the p series will converge when the power is greater than 1. Then p has to be greater than 1/2. And then for this one, we have a geometric series, and the geometric series will converge as long as whatever is inside is less than 1. So then p has to be less than 2. So then between yeah, and then those are not included also. So it has to be less than 2 and bigger than 1/2. So for 27, the answer is C. All right. Just remember those are not included. Okay. Let G be a continuously differentiable function with G of 1 equals 6, G prime of 1 equals 3. What's the limit of blah blah blah? All right. So if we plug in if we do direct substitution, so we just plug in, we get 0 over 0, which is an indeterminate form of the limit. So then I can't evaluate it. And then what I would do is just do the L'Hopital's rule. So then that means the limit. So on an FRQ, you have to prove why the L'Hopital rules apply. You would take the limit of the top, that's equal to, usually is equal to 0, and then the limit of the bottom also equal to 0. Since they're both equal to 0, it will result in an indeterminate form. Therefore, you can use the L'Hopital's rule. But then for MCQ, I'm not just worrying too much about it. So it's just that one. So integral from 1 to x of g of t dt over g of x minus 6. That's equal to limit. So the L'Hopital's rule, it only works if you have an indeterminate form. If you don't got an indeterminate form, it's also sad. You can't use it. I'm sorry, I messed this up. So then that's just equal to g prime of x if I take the derivative. G of x is equal, so g of 1 is equal to 6. And then g prime of 1 is equal to 3. So then this is equal to 2. So 28, the answer is D. All right. That's it for the first one.